Now we have other data types. These are formed from the fundamental data types, which are list, um, dictionaries, then we have set, and then we have tuples. Okay, all right. So now we'll be going over one by one, starting off with int. Now, int is just integer. Any integer value you give, it will just consider it as int. So let's say a equal to 6, and one handy thing that we will use over here is type. Type function pretty much tells you what type a variable is. So when I just run that, you should see the output as class int. Yeah, Python is kind of slow, but yeah. So we have class int over here. Now, if I directly gave this as 6, that should be the same thing too. Any argument you give, it would simply return the type of the argument. So now let's move on to float. We'll come back to our basic operations on int and float a bit later. So let's move on to float. Let's say b equal to 6.0. And now when I print this, it should give me a class float, as it would even in say C or C++, it would be returning float. But say in C or C++, we have something called as double. Uh,
Uh,
that
Hey,
concept is not here.
sorry to interrupt,
Uh-huh.
Ganesh. Could you increase the font size a bit?
Uh,
Yeah,
is it better?
thank you.
Ganesh, are people trying to join?
Yeah. I'm just admitting them when they're trying to join.
Oh, you can admit
Cool.
them, right? Do you have a problem with that? No, right?
No issues. It's fine.
Okay, please, go ahead.
All right. Now the third data type we have is strings. Strings in Python, you can enclose it within double inverted commas or single inverted commas. Unlike in C, even if you use a single inverted comma and say, something like that, it's not going to, essentially throw you an error. It's going to treat it the same way as it would treat a double inverted comma. So now if I say print and go with type of C, and that should return me class string. Bool. Okay, so now when we're talking about bool, one thing to remember is that in Python, your bool characters will start with a capital letter. Uh, there's an issue with kind of Python and online interpreters because they're kind of really slow. Um, there's a reason why Python is slow. You guys might learn about that later or maybe if you guys are going to ML, you guys will learn about that. But yeah, right. So now we'll go ahead with print type D. All right. Now, obviously, this is going to return class bool. Now, coming to operations on in Python, right? So we have int, float, and bool. With these three, you can perform operations however you want, right? You can simply just have a plus b plus d, and it's not going to throw any error to you, simply because true would be considered in Python. You have true would translate to 1, and the other numbers are directly you can add them, so it doesn't matter. The only constraint in any of these three in having in operations using int, float, and string, sorry, int, float, and bool, would be that you should not divide by 0, and naturally false would be considered as 0. So only if you divide by false or divide it by absolute 0, you're going to get an error. Other than that, you can do any operations with any three of them. Okay, but now coming to the other part, which is string. You can't say directly add a string, right? So maybe if some of you use JavaScript, you guys know that you can do that in JavaScript, but not here in Python. In Python, you need to do something called as casting, right? So okay, fine, this is taking a all right, yeah, okay, all right. So let's wait for that to happen, I guess. Okay, just a second. Let me just reload this thing. All right, cool. So naturally, you can't add a string to a float or any thing for that matter. You can't add a bool. You can't perform operations like that with a string, obviously. So for that reason, we will be using something called as casting. So essentially, we would be doing something like this. We would convert this part to a string, and then we will be adding that to it. So which would result in something like 13.0 and then 5.0, right? And that's what we expect too. Um, Now, let's say you were supposed to do this in C or C++, right? You would have to handle this in terms of ASCII values, right? But in Python, you just have to simply cast it as a string. Now that's cool, but it takes a toll on your time. So that's the reason why Python is slow. Python in the inside, it works on C itself. So it's built using C, C++. But since it is built using C, C++, it has a lot of constraint. It has to call a lot of functions. In contrast, if you were to directly implement a function in C, C++, it would be much faster. But however, since the syntaxes are much easier in Python, we go ahead with a lot of things are possible with Python. And especially because Python uses an interpreter and not a compiler. So we'll come to that. That's a little bit of an advanced concept. When you're going into your actual SMPs, you guys will learn about that maybe. But yeah, for now, we'll move on. And right now, we will be looking at something called as immutability. Now, what is immutability? Right. So say in C, you wanted to change this to typo, right? So I wanted to say that C is typo, and now I just wanted to change it to typo. So I would say something like C of O is equal to P, and then I would print C. Now this should actually work, right? So this should let's comment this part out just so that we can make it a little faster. So yeah, this should work, right? So this should essentially give me the output as typo. But unfortunately, in Python, strings are immutable, which means that you can't change uh, a string as such. So once you declare a string, right, this is taking an extreme amount of time. All right, okay. So I'll just continue with my explanation. When the program loads, let it load. Right. So the strings are immutable. So essentially what this is going to do is it's going to throw an error because you can't simply take the value of C of 0 and change it to T. What you can do is you can access the value, but you can't simply change the value. Once you have declared it, the entire unit remains together. And in order to change that unit, you will have, in order to change it, you need to completely initialize it with another unit. So if I had to, change it to typo, I would have to change the entire variable C to typo. And this is the only way that you can do it in Python. Though you can, try to replace and make, methods for string, in essence, it's going to still be the same thing. And that's simply because Python is immutable. So when you're going to hear something like strings in Python are immutable. So when you're going to hear something like immutable in your interviews or what it is, this is the thing that you have to be looking at, right? This property also goes over to tuples, which we will be looking at later. Okay, man, this is taking a lot of time. Great. Okay, fine. All right. Just a second. Okay, all right. I just wanted to show you guys that this will be throwing an error. Let's go ahead with that. That and that gives you an error. So that's because string does not support item assignment. So if you're looking at an error that says you can't assign an item, you should know that either the form is a string or a tuple. All right. Now, these are the fundamental data types. Now, these are the building blocks of the next four data types: lists, dictionaries, sets, and tuples. So let's take a look at list first. List is simply a collection of items. When you have list, it would simply mean an array in C. So let's say I have a list and I initialize it like this. I open a square bracket. I say A. I say 12. I can go with true. And this is possible in Python, though in C it would not be possible. You can't like use different data types in an array, right? But in Python you can do this. You can go ahead and have different data types. So this is not going to throw you an error. And if I wanted to simply access uh, list the first element, I would go with list of 0. Great. And say I would do class string of list of 1. That's acceptable too. Perfect. Now lists they have a lot of significance, right? So you have a lot of list methods. These methods help you. Right now in this SMP, we'll not be looking at the methods because it's going to take a lot of time. But just know that you have methods for finding lists. And another very important thing that you should know is that when you access list of -1, it returns to you the last element of a list. All right. So when I go with that, it's going to return to you true. And -2 is essentially going to do the same thing. And it's going to go in like a circle. So if you exceed the maximum limit, it's going to go back to the last element again. Right. So this is list. Lists are basically like arrays. You can think of it that way. But the only difference being that in list, you can have different data types. Now, moving on to, let's go ahead to tuples right now because they are very similar to lists. Lists and tuples have only one difference. That is, tuples are immutable. So I have, let's say, a tuple, and I assign it to, let's say, A12 and true. And pretty much I can do the same exact thing I did over here. And that's still going to give you the same exact output. But one thing that I cannot do over here is that I'm going to say list of 0 is equal to B, right? And here I'm going to say tuple of 0 is equal to P. Now, let's just go ahead and print list of 0, and the program execution will terminate over here itself, but we're going to go ahead and print it anyways. So over here, we're going to have B over here. That's because of line 23. It's going to say you can assign it. But when you go over to 27, it's not going to allow it because, again, tuples are immutable. Now, why is this important? Let's say you want to have constant properties. Say when you're going over to Django, you have to make some choices. Now, these choices should not be changeable, right? So if they're changing, then that's kind of like a security breach. So you want these to be fixed. So that time you use tuples so that people are not able to change it from the outside. You'll learn more about this, in your actual SMP, but yeah, this is the brief about it. The next data type is sets. Sets are very, very important, I would say, especially when you're doing some backend work, mainly because set and list tuples, they're almost the same thing, almost, except in sets they have the same exact property of your mathematical set, right? So you can apply your difference, you can apply your intersection, you can apply your union on these set elements. So let's say SE kind of set is equal to, and then I'm going to use this open curly brackets, and then I'm going to say 2, 3, 4, and whatever, right? So now what happens is that in a set, it's simply going to implement it normally. So set print SE of, oh right, yeah, never mind. For item in SE, like we're going to look at loops in a while, but think of it just like we're just going one by one in each item. So yeah, right. So now in sets, we have 3 items in our set, and it says 2, 3, and 4. Great. Now why is set more important? Because let's say I'm going to add 4 again. All right. You can't store another. There's you in a set. You can be 100% sure that there is no duplication of an item. So if I run this again, I'm still going to get 2, 3, and 4. Whereas let's say if I were to do that in a list, right? Okay, let's just change this to a list right now. It's though the naming is SE, it is a list right now. It's going to give you 4 2 times because duplication is allowed in list. Fundamentally, even if you think about it in mathematics, in a set you can't have duplicate of items, right? So because of that, it allows you to have intersections, differences, all these you can apply on a set. So again, I'm not going to show the methods for you over here because it's going to take quite a long time. So the only thing that you need to remember is that in sets, if you're going to have duplicate of items, it is not going to allow that, and it is mainly because it's going to use it in an effective memory storage kind of way. But again, we're not going to get into the details of it. Now with set being done, we will go over with dictionaries. Dictionaries are hash maps in C++, right? So for dictionaries, I'm simply going to give dictionary. Okay, wow, equal to, right. So in, let's say, a list, we have indices. We have 0, which corresponds to a value, 1, which corresponds to a value. In dictionaries, you can think of indices as user given. So you can just say that I'm going to say A corresponds to, say 65. My bad. A corresponds to 65. And then go ahead with B corresponds to 66. So this is something like we're saying take a list, and instead of calling it a list of 0, I want you to call it list of A. Essentially, that's what we're doing it. You can think about it that way, but this has a lot of uses when you're going into actual programming. One more important thing is that these are called as key value pairs, and for you can have any type of key, any type of value. The key that you're giving should be immutable. Why immutable? It should not happen that at a later point you're able to change your key and then say, okay, let's just try it out. If I give it a okay, wait 1 second. So as you know, strings are immutable, and right now I'm going to say print dictionary of A, and that would return to me 65. Perfect. And you guys do remember that tuples are immutable, so I'm going to give tuple of 12, 13, and that should again return to me 65. Great. But now let's say I'm going to change this to a list, right? So I want to try making it into a list, and that would throw an error because when you're talking about, oh my bad, that's not the error. Okay, so when you're talking about, let's say, a dictionary with, you should remember one thing in dictionary, that is always your keys should be immutable. The one more effective way is effective thing about dictionaries is that one key can only have one value pair. So this actually helps. Um, right, then would I still be able to change an element if I had created a character array instead of a string? Yeah, if you had created a character array instead of a string, I mean, technically you call that a list here, and if you had created the, so if you're creating a character array, then it would be considered as a list, right? So what you would essentially be doing is that you would say that list is equal to f, y, and e, and oh, that's what you'd be doing. This is a list of strings. Though I get what you're coming at. In C, we count a string as an array of characters, but not in Python. In Python, a string is as such a string. So it's not like, it's a array of anything. So that's a difference. So if I just printed list, it would not directly print. So if it would be accessible, you can change it. But if you are going to implement every string as a list, it's going to have two things. One is for printing every word, you would have to use a for loop. That's going to take a toll on your time complexity, and also it's going to take a toll on your memory naturally, because instead of one string, you're going to store four different strings, right? Okay, so that concludes all our data types. So I would like to stress on the last point that I told. In a dictionary, when you have right, what's the difference between a list and a tuple? A list is not immutable, and a tuple is immutable. So when you're initializing a tuple, you cannot change the characters that you had. You cannot change whatever you have done. Okay, I'll come back to the doubts at a later point. Um, so what I wanted to tell was that when you have a dictionary, one key corresponds to one value. So if I wanted to, say A, and then I would go ahead with dictionary of, again, let's go ahead with this itself. A is, let's say, 7. That's kind of wrong, but we don't going to care about it. Right. So it's going to take the last one, obviously. But like I said, one key, one value. You guys got to remember this. Also, when you guys are using, you guys are entering competitive programming, you guys will exploit this fact a lot in C++, I mean. But yes, so this concludes our data types. Now we will be looking at conditional statements. See, in Python, the conditional statements are simple, right? You have if. Let's have some Boolean values. Let's say EL1 is equal to true. EL2 is equal to 5, and let's say EL3 is equal to 6.7. Great. Now we have if and we have conditions. Let's say if EL2 greater than, let's say, 6, and in say C++, your and symbol is this, but that would be replaced with and over here just with the word and let's say EL1. Now the important thing for you to note here is that once you press enter, you have an indent over here, right? So you have a two space indent over here, and this indent is what is corresponding to a bracket for you in C or C++, right? So whatever comes within one indent is a part of that if statement. So I would say print, let's say this is within if, and it's going to print that. So the second I go outside and print this is outside if. So right now, this is within if is not going to get printed, obviously, because our first condition is not satisfied. If I, however, change this to 4, it should be satisfying, and both the conditions would be printed. Now, let's say I move this statement outside with an indent, and that is still going to execute the program. This is my bad. This is also within if. So let's say I move that to there, and then I change it to 6 back, and both the statements are not going to be executed. Now, we have in whatever we have in C++, else if we here call it as elif, and let's say el underscore 3 is greater than okay, less than 7, then print this is within elif. Great, beautiful. Now, wow, that's throwing. Oh, never mind. So now that this statement did not get executed, it's going to go to the elif and then get executed, and then you have a simple else statement, and it's the same thing as C or C++. All right, within else. Great. So this is how see now obviously. So if I had done this, it's going to go to the else statement. Now coming to nested ifs. So if I were to put an other if over here, if let's say 6 greater than 8, so now there would be an other indent over here. So anything that's coming into the next indent would be a part of this if. So that's how Python is going to interpret. Make sure that our indents are on point, and when you're collaborating in a project, you have to make sure that your peers are also using the same exact indent as you are using. Okay, so if someone uses a tab and someone uses a space for the indent, there's a probability that it might throw an error. Okay, so you have to make sure of that. This okay, all right, just print whatever you want. Cool. All right, so right, so this is not going to get printed. All right, great. Now I also wanted to talk about comments. Now that we're done with the conditional statements, if you have any doubts, I'll clear it at the end of the session. Now wanted to give you guys a brief about comments. So in Python, you can have two types of comments. One is you can go ahead with a hash, and then you can say this is a single line comment. And then you have multi-line comments, and for multi-line comments, you're going to have 3 single inverted commas, and then you're going to put again 3 single inverted commas, and within this, whatever you're going to add is multi-line comment. So obviously, both these statements are not going to get printed, or neither are they going to throw you an error, which simply means that these statements are completely within. These statements are completely allowed. Cool. All right. So these are about comments. Quite simple, actually. Now, with conditional statements being done, we'll move on to loops. All right. So in Python, we have 2 loops while for, but for most of us, we're going to be only using for, and that's what I'll be explaining right now. say you have a list, all right? So this is a list. One way of using for is for each. So if I were to use for each, I would say for item in list, this list, print print item, all right? That's simple. It's just going to print the item, A12 Great. There's another way to use for loops, which is how you use it by I equal to 0 things. So that you would use by saying that for I in range, the range of number you want to use it till. So let's say li of 1. You would go ahead with print I. So this is going to print numbers from 1 to 12. Sorry, 0 to 11. My bad. Beautiful. It's taking a lot of time. All right. So what range is? Range is we call range as a generator. Generator will generate a sequence of objects uh, given a number, given an argument. Generators are a little bit of an advanced concept in Python. So maybe you guys should like try going back and looking up what generators are. But this is the gist of how you'll be using for in these two are the only mostly these two are the only ways that you'll be using for in Python. This is pretty much same as using C or C++. Now that being done, I hope that's clear. Quite simple. Now that being done, we're going to go with small input and output. Obviously, output is straight up print. All right. So if you wanted to print something, this is in std out. Okay, this is in out. Go ahead with that. It's going to print that. Now, if you let's say you print this and you now print this. Now, it's going to print it in a new line, if you would see, without me even having to give a slash n. Now, what do you do if you don't want it to come in a new line? You're going to give end equal to this no character, and that would make sure that, okay, let's just give a space over here. That would make sure that your end is not a slash n and it is a simple space. All right. Now for input, now let's take input that is, let's say a equal to input of enter number. Now know that the argument is a character, right? And let me just remove this part of it. Now the argument is a character, and what I want to show is that it is all right. Let's go ahead with the type of a firstly. Okay, great. I'm going to enter say 2. I'm going to give us a type of string. Now that's very important because when you take an input, it's going to input it as a string. Now, if you want to handle it as an int, then you need to specifically typecast it into int, and then you need to have your operations with that. All right. So I would say type of a, and then print, let's say a times 7. Now this is valid right now. Say that's 5 and 35. So this is about general input and output. So whatever you're giving over here is going to be your argument, and that's going to ask you over here, which is making things really simple with respect to, let's say, C or C++. And that's about it for the Python session. I hope you guys had a basic understanding of Python. The floor is open to doubts. If you guys have any questions, you guys can ask. Go ahead, Aniket.
Like what exactly does a dictionary do? Like a list signifies like it is like arrays in C++. Like then
Yeah.
what is dictionary here?
Dictionaries are in C++. It's a hash map. right? So when I want to say, okay, let's have this list over here. Let's make list is 65 56. Now, in order to access the first element of a list, how would you access it?
Li of 0.
Exactly. Yeah. So now you would access it as li of 0. Uh, let's say um, let's say I have a dictionary. Let's say I want to have you know a I want to store the heights of different people in a class, and I want to store it. Let's say using their name, right? One way you can do it is using their roll numbers. So you would directly go with LA of 0 would simply represent say roll number 1, and you can go on with that. But let's say right now I want to make correspond it to a dictionary, right, of names, right? So in that case, what would you need? You would need two lists uh, in which let's say 0 would represent the height of that person, and in list let's say 0, the zeroth element would represent say the height of the person, and let's say in list 1 um, it would represent, let's say, yeah, she's shorter actually, but yeah. So let's say this would represent something like that, right? So I would say li of 0, that's Aniket, and from that you can say li of 0, his height is 165. Now those are two different lists they are trying to store, right? But instead of that, I could go ahead with Aniket over here and say that his height is 165, and say uh Josh, and go say that his height is 166. This is making things much simpler for you, right? So if you go ahead and type Aniket, it's going to simply return to you 165. So this has a much easier mapping when you deal with larger amount of data. But when you're having smaller amount of data, I think less, like when you're quite precise on what needs to be where, lists suffice. But when you're having larger data, you have to go with the dictionary. Does that make things clear for you, Aniket?
Yeah, and like basically here, in dictionary, Aniket is index and the 165 is its value, right?
Yeah, we call it as a key,
Okay.
but it translates to an index. You can think of it like an index, right?
Okay. Thank you very much.
No problem.
So can we link the two lists just like a dictionary?
Mm-hmm. You
I'm
can.
asking.
Yeah, yeah,
Okay.
you can. You can build a method for it also. Like you can build a function for it. I mean, you can. Yeah, you can do that. You can just say that for each item in list, you can go with, or you can go with list.length. List.length is going to return to you. So something like for I in range of li underscore 0 dot uh, I'm sorry, length of li of 0, and then you can have something like dict underscore 1 is equal to okay, or we can have it something like, yeah, so you have it something like li of I, I'm sorry, this is taking a little bit of time to code out, li underscore 1 of I. um, Prerequisite, you gotta have dict underscore 1 as an empty list, oh sorry, as an empty dict. So this is gonna do the work for you, right? So you know that for sure. I'm sorry. Oh, okay, yeah, my bad. I have this over here. Cool. So you know that for sure list of 0 is going to have the same number of elements as list of 1. If that knowledge is given to you, you can simply implement this and have a dictionary out of it. Does that make it thing?
Okay.
All right. Anything else? You can use Python faster than this? Yeah, I could have used a lot of other stuff, but thank you. How to initialize a variable which takes anywhere between 0 and 1? Uh, Depends. You have to use like constraints for it. There's nothing specifically that should have it between 0 and 1. Which IDE are you using right now? I'm using Repo. It's an online code editor, but if you guys wanted to use, you guys could like directly install Python and then use BSC, which would be way faster for you guys. Any other doubts?
Can you please explain like 38 line again? Meaning of 38, sir.
Oh,
Dict
okay.
underscore.
Yeah. So right now right, my bad. This is this underscore 1 and then this underscore 0. Okay. So now when I access the list 1 element 0, I have Aniket, and I want Aniket to be initialized to 165. So what I'm going to simply do is that I'm going to have an empty dictionary, and then I'm going to say for every element, I'm going to use it not in an element kind of way. I'm going to use it in an index kind of way. So take the length of list of 0 or list of 1, given that both of them are the same number of elements. Take each index, go to that index, okay? Find out the value that index holds. So in this term, we will start off with 0. Length of li of 0 would return to me 2. So we would start off with 0, and then it would say li of 0. Li of 0 is Aniket. So simply you can replace this with Aniket right now. Is equal to li of 0 of I, and I of 0 is 165. You get it? And the
Yes.
next iteration, it's going to go ahead with 1. Li1 of 1 is Yash, and then it's going to initialize it to 166. And that just keeps going.
Okay. Thanks. Thanks.
Are there any other doubts regarding this? We're running a little late, I guess. So I'll hand the session over to Gaurav. Gaurav, floor is yours.
Hey, hi guys, so how's it going? So I'm going to give a session on Git. So let me share my screen. It's visible, right?
Yeah, it's visible.
Yeah, so Git is like the most widely used version control system. So what is version control system? Is basically it's used to track changes in your code, and it's like adding checkpoints. So like you're playing a game, and like if you lose, then you can go back to that checkpoint, and this is what you do using Git also. So to install Git, you can use this website. I will share it with you so that yeah. So you can install Git, and then to just set up Git, it's the first like you just have to do one time. So like I just have to do git config global user.name, just my name and my email similarly. So it will set up, and this is a one-time thing. And now like we're ready to use Git. So I have a basic folder ready, Git basic. So like if just imagine that this is the code base that you're working on. So there are like many files in this code base. Right. So you made a lot of changes. So like you've made a lot of change, and now you want Git to track all the changes that you have made. So it's very simple. Go to one second. So yeah, go to your the directory of your code of your repository, and just type Git Init. So what Git Init will do is it will initialize Git inside that repository. So now you can see like it's showing you. Basically, it means that Git is tracking. So if you actually see the folder, the .git file has been created. So that's what this means. Now I want to if I want to see what all changes I've made, so I can write Git status, and what it will tell is that there are two files and they're untracked. Basically, we haven't added them to the staging area. Staging area is an area where you add those files, and over there you can commit those files. So basically, if I want to add everything to the staging area, I can just type git add dot. Dot means it will add everything to the staging area. So now if I type git status, it will tell that now these two files are ready to be committed. And then I can type the command git commit -n. -n means this is a message for that commit. So usually while writing the message, you want to be a bit descriptive about what changes you have made, what code you have added extra from the previous commit. Since the first commit, you can just write first commit. So now it has been committed. Now that's a checkpoint that has been created. So if you do git status, you'll see there's nothing because that now the working tree is clean. So I'll just add more changes, and then we'll see what's the use of tracking. So like this, and now I see that these two files are again modified, and then I can just write git add dot. So now they're again in the working tree, and then I can commit it similarly. So yeah. So now if I do git log, which will tell me everything that I've done, that all the commits that I've added, and it has told me like this is the commit, and this is the hash of the commit. This is another commit. This is the hash of that commit. So these are the two checkpoints that has been created. For example, if I have another commit, yeah, so now I realize that I've screwed up. So now I want to go back to another version of my code. So these three versions have been stored. Now I want to go back to this version of this code that is, so this is the hash, like it's a very unique hash for every commit. And I want to go back to this. I don't want to continue with this. So I can just type git reset, and hard means like all the changes that has been made will be deleted till this commit. And then I will copy this hash. So basically now it will know that I want to go to this particular commit, and now head is available, and you'll see that all the changes that I had made has been deleted. So all the changes that I had made in the third commit has been deleted. And if you do git log, you see that there are only 2 commits left. So now we have gone back to the previous commit. Yeah. So either instead of using that, if you just want to go back one commit, you don't want to go back to a particular commit, you just want to go back one commit. So you can do git reset hard head, and add one. So one means it wants to go back one commit. If I want to go back 2 commits, I can do 2 commits. I will do this, and again all the changes has gone. So this is how you use Git for your local repositories. But many times you want to put your code in a remote server, in the remote repository, basically in GitHub, so that others can collaborate, others can contribute to your code, or like if you are working in a group project. So I want to create a folder in GitHub so that I can others can see my code, and in case my laptop just stops functioning, then I can just use GitHub to recover my code. So I'll just make a new repository just by name Git basic. Yeah. So it will create the repository. Now I want my local Git to know that the remote repository is like, this is my remote repository, and you want to push to this repository. So for this, you will use this command. So what it means is git remote. Remote means you want to add a remote, add origin. Origin is a name, so I can just make it anything. I can make any name. By convention, we use origin or upstream, and then this particular URL. So basically, whatever repository is in this URL will be added as a remote, right? So if I just add this, now if I do git remote to just check if there is, and you'll see that there is a remote repository that now Git knows about, and I can fetch from it. Basically, if somebody else has added code to that repository, then I can fetch from that so that I can update my local repository, or I can push to it. Right. So now I want to push my code, whatever code I've written, to that remote repository. So I can just do git push origin. Origin is the name of the remote repository. That's why I name it origin instead of writing the entire link. And then master. So what is master? Master is basically the branch. So a particular repository has a lot of branches, and so basically, like for large code bases, different branches will have different work happening. So like since our branch is master, which we can verify using git status on branch master, so I just push it to git push origin master. It will ask me for my credentials. Yeah. So now it has been pushed to the origin in the master branch. So if I refresh, you'll see that now it has been it is available in the remote server. So now anybody can commit, anybody can contribute to your code and everything. Yeah. So now one problem that occurs is that somebody wants, if there's many people that are contributing to your code in this remote repository, so just assume that this is somebody else who created this code. Yeah, and usually this is not a best practice, like to just edit from the remote. But if we are editing from remote, now my remote repository will have no idea about the changes that has been made in this. So like I made a change, but you see that it is not available here. So to update my repository, to update my local repository, the one when the code is in my system, I can just do git pull as in pull fetch. So as we saw, there's a fetch, so I can fetch from this link. So if I do git pull from origin remote repository and master branch, so now as you can see, now this has been added. Yeah. So yeah, this was the basic introduction to Git. There is a lot of learning curve regarding Git, and like once you get used to it, more you use it, then you'll get more better in using Git, because Git has a lot of advantages, and it's really good to use Git while working on your projects. And so yeah, I'll send you a link to refresh yourself with Git commands. There are a lot of Git commands, so you can just learn all this. So yeah, this is it for Git SNP. So if you have any doubts, you can shoot. What is a remote repo? It's like a mail server.
Like when I am downloading like Git, like it is showing the error like another program is using this file.
What is the operating system?
Windows 10.
Some other program is like it's very like. Are you able to download the?
Yes, I have done. Like when running the exe file. Download it.
Try to restart your system once and then install it again.
Okay.
So to answer this question, what is a remote repo? So remote repo is basically in GitHub, whatever the repository, like your repository in GitHub in that server, and it's still a distributed system because the version of the code is still available in your system too. In everyone's system who's able to contribute, the version of code is still available. So like it is distributed amongst all the collaborators. So yeah, it's still a distributed system because there's not one particular place. It's not centralized to one particular place where you can contribute. And so yeah, it's all the versions of your of the remote repository is available in everyone's system who is contributing to it.
Guys,
So
is
is
Git
there?
properly clear for all of you? If you guys have any doubts, shoot right now because Git is going to be very important for you guys once you start collaborating on projects. All right, we'll wait for a couple more minutes and then we'll start off with we'll end the session.
Yeah.
All right, guys, that's the end of the session. You guys can leave if you guys have other SMPs. Thank you. Hope you guys learned from it.
Thank you.
Thank you, guys.